agents. Please take a look at this top secret video just received.
Hi, this is Mr. Jordan. For today, I'd love to help you out with systems of linear inequalities. Now, before we get started with this, I just want to give you a quick definition. A system of linear equalities is a set of two or more, you guessed it, linear inequalities. Now, you'll notice that this definition looks a lot like the definition for a system of linear equations, which is pretty non-coincidental because it's almost the same thing except we're dealing with inequalities instead of equations. The other main difference here is that we're finding a solution set. We're not simply finding one solution, but we're going to find that the solution will be represented by a region. So in order to find a solution set, we're going to graph each inequality and then go ahead and find the region of intersection, and not simply just one point of intersection. We'll see how all this plays out in an example here. So we have y is less than 1/2 x minus 3, and y is greater than or equal to 3x minus 1. Now we're going to use all of our rules that we have for graphing inequalities in order to graph these two inequalities and the regions represented. So let's do it. So here first we have y is equal to, or y is less than 1/2 x minus 3. First thing we're going to do is we're going to graph this line. So we have a y-intercept of negative 3, which I'll put here. And then our slope is 1/2. So we'll get a few points with that slope. And then I'll go ahead and draw the line corresponding to it. Now we'll note here that because we're dealing with a less than or equal, or a less than graph, that this line is actually going to be dotted and not solid. I'm going to go ahead and do some dotting here. There we go. So we have the dotted line, y is less than 1/2 x minus 3. And we see that because we have a y is less than, we're going to go ahead and shade this region below our line. And so all of this, the dotted line and the shading below, represents y is less than 1/2 x minus 3. And there's our shading. I'm going to do the same thing with y is greater than or equal to 3x minus 1. So here's our y-intercept at negative 1. And I'll go ahead and mark a couple of points. It'll help us to determine our line here. And now I'll go ahead and graph it. And you'll see that because we're dealing with a less than or equal or greater than or equal to, this line is going to say stay solid. So here we have the solid line. And we see also that because it's greater than, we're going to graph, or we're going to shade above the line. So I'm going to go ahead and do that. I am shading the region above this line. There we have it. Now what we want to do is we want to find our solution set, which is represented by the region, not just the point, but the region of intersection. And we can go ahead and spot that by looking for a region of this graph here, or of these two graphs, that has both shading styles in it. And it seems to be this little chunk of the pie right here. So I'm going to draw a nice little arrow directing us to that right there. This little region and everything sort of below it, if we stretch out these lines, is going to represent the solution set of this system of linear inequalities. We see here that we have a shaded line, which means that the points on this line belong to the solution set, but the points on the dotted line do not belong to the solution set because those are points that are less than this line, and we're not dealing with those. So we want to deal with all of the points in this region, not on this To review, when graphing systems of linear inequalities, we're looking for a solution set. We'll go ahead and find that by graphing each linear inequality separately, and then looking for the region of intersection. Great job.
Agents, I hope you found this information helpful. Go ahead and use this to solve your mission.